left-hand circular, or you can have horizontal or vertical.
Yeah, I think you can have linear polarization as well.
Yep.
But that's what that little box has. It's got the relays in it and the delay lines in it. So
They're in there. Yeah.
yeah.
Got about a minute before the meeting's supposed to start.
Read.ai meeting with a microphone.
Yeah, somebody requested it. I gave them access.
Oh.
You're already recording, Lloyd.
I got mine paused, but
Says it's
somebody asked for AI recording,
Oh,
so somebody is recording. We haven't started yet.
what's the difference between AI recording and recording?
You got me. I've never done it on this end.
Well, the AI is recording all the time.
Yeah, it does the minutes and whatnot.
I think once you set that in the master settings, you can't turn it off for the meeting.
Does that go direct to China?
Probably.
For their new cheap AI?
Yeah, apparently.
Well, it's real cheap because if you get to steal all the training material that everybody else has paid for.
Yep.
What the hell?
I don't know. Don, all the companies I worked for, we couldn't push the technology to them fast enough.
Yeah, no,
So don't blame the Chinese if we're forcing it on them.
No, I don't. Well, they demand it if you're going to do business with them.
Oh no, we demanded that they take it so we could do business with them and have them build all our stuff cheap.
Exactly.
Why reinvent the wheel?
So yeah. All I'm saying is it's the American companies that are in the past have done this.
Have done it. Yeah, that's true. Yep.
So everybody wants to blame the Chinese, but they're just out there. I had a friend that said, it's easy to compete with the Europeans. Shoot, they take 6 weeks of vacation a year. Right?
Yeah.
He says, but the Chinese, that's a whole nother story. He says, those people live in a cardboard box and eat a bowl of fish or a bowl of rice and fish head for dinner and be happy for it.
Yep.
18 hours a day.
Yep.
Well, and apparently a couple of 3 pundits have it that their population is declining like crazy and their workforce is going to shrink.
Well, up until 5 years ago, they had the one-child policy.
Yeah. All right.
And so, so their main population is aging out and the next generation isn't coming up into the workforce yet.
And there weren't enough girls being born either.
That too, they would terminate girls. So
yep.
Well, got 16 of us here. It's about wait a few more minutes till we get maybe a couple more added, and then we'll officially start the meeting. Let me throw the agenda up here.
I'll start recording if you want.
Okay. With introductions and briefly talk about the current Board of Directors elections. We've got a few more days left before we close the that elections up for the that. Oh, and I got you up first, Bill, for the science fair info. Then we'll get into Dan's presentation.
Okay.
So shouldn't take too long.
You want me to do that now?
No, let me wait till we get officially started here. Let's see if anybody else has come up. I got 16 people logged in right now. We usually end up with about 22 to 28. I think the biggest group we ever had was about 32. It just varies from week to week. So, let me stop share. Oh, still got 16 here. As far as introductions go, we can start the introductions. This is the official science meeting for February 24th, 2025. And we introduced the board of directors, current board of directors. We got Floyd running the show tonight on Facebook or on what's this called?
Zoom.
Zoom, yeah. So many platforms out there. Don Latham with the caricature there of a something he dug up in his backyard, I guess. Then we have Paul Sabone, Bill Miller, and Dan Lane, who will do a presentation. So we got and myself. So we got I think all the board of directors here. Oh, we don't have Rick. Rick's not on board yet. Sometimes he shows it depending on Rick's work schedule. Sometimes he's crunched for time doing work. So anyway, good evening, everyone. We got 16 folks here right now. We'll probably gather a few more throughout the night. And if we find somebody we don't recognize, I don't recognize the Read AI meeting. It might be Larry Stewart. He was in here earlier and had issues with the with his audio. He couldn't hear anybody. We could hear him fine, but he couldn't hear us. So if that's you, Larry, put a note in the chat window and we'll recognize you there. So start the meeting with the, I just talked about the board of directors elections. March 1st is the last date for ballots to be received. The board of elections committee consists of Floyd, who's not running anymore for the secretary's position or board of directors position. We have Bill Miller, Dan Lane, Rick Hambley, and myself. We'll be counting the ballots and tabulating who's going to be the next 3 board of directors. We're electing 3 out of the 4 running right now. So more on that later next week when the ballots are officially received, and we'll get that information out to everybody. Then the officers, the 4 officer positions, president, vice president, secretary, treasurer will be voted. According to the bylaws, they're selected by the board of directors. So that's how that works out for the DSES slate for the officers. So any questions on that before we get into the school science fair? This is something we do every year. Bill Miller's been heading this up for the last, 4 or 5 years. It started out by another individual, and then he kind of dropped it in Bill's lap. So here we go, Bill. It's all
Hey,
yours.
Myron, you asked for questions. I just wanted to ask one question.
Oh,
Are
yeah.
are you sending out any reminders?
Oh, yeah. I've sent out reminders to we collect all the ballots by name that could send them to us. Then I send reminders out to those voting membership who have not voted. So
Okay.
if you voted, you will probably not get that email. It only goes out to those individuals who have not voted.
Good answer. Thank you.
So yes, I've been sending that out. Send one more out probably in tomorrow or the next day. And I have been getting that first one went out over the weekend or Friday, and I got 3 or 4 more votes in, or more, 4 or 5 maybe, I don't know. But it has jolted a few people. And I got some dues in, renewing dues, which means they can vote. And they've got their ballots as well and voted. All right, Bill.
Okay. Can you see this?
Yes.
Yep.
Oh, okay. For Science Fair this last Saturday, this is the Pikes Peak Regional Science and Engineering Fair. It used to just be Science Fair, but with the Science Olympiad taking a lot of the students that would have gone to Science Fair, they decided to expand it to Science and Engineering Fair. And that makes it a little more open where you can actually do projects and demonstrations. It doesn't have to be specifically a science project. The science projects were pretty restrictive in how you had to present them and you couldn't do things like demonstrations and engineering projects in the science fair, but now you can. So that expanded a little bit. So they got a junior and a senior division. This year, Roger Oakey and his girl Barb and Bill Thomas and I all judged, and we split up into two teams and started at opposite ends of the of the um, uh, the participant list and worked through those items that we thought were more applicable to the things that we do, more engineering, more space related, more microcontroller related, those sorts of things, rather than like the earth sciences and the natural sciences. So we tend to leave those for other groups to do special awards, and then we kind of focus in on things that might be kind of in our bailiwick, so because that's kind of what we're the most familiar with. So we gave 4 awards. This one here is for I don't know if I can pronounce his name correctly, but I believe it's Janelle Parika or Parik, and he did a project on harnessing waste, powering the future. Build a whole little project on a waste recycling plant, all on a board, about a 3x4 board on the table, and showed how that could be done. And it was pretty well done, and he was very well spoken. And this was I believe, a 7th grader, and so we gave him top for the junior prize. And then see if I can get the next one. Okay, so and this is one for Lily Prime. I love these kids' names. I mean, they're you can just see these kids going on to be scientists with their names. This one was for analysis and comparison of gravitational wave event parameters. And she didn't really do an experiment, but she went out and researched the national databases for the gravity wave observatories, and was actually able to go into the database and collect and analyze the data and sort out the data to find actual instances of gravity waves and collisions of black holes. And so that was pretty interesting, and taught us a lot about doing gravity wave analysis and finding those events.
Do you remember which school she went to?
I could tell you in just a second. I usually there's not enough room on my chart for the schools, but I can tell you which school she was. That was Lily Prime. That was gravity wave. That's Palmer. So she's a Palmer student. So that's not surprising. But we had one from Pine Creek, one from Palmer, one from let's see. I'll get to it here. Let me go on. And this was second place in the junior division was Nikolai Laptev, another great name for a scientist, maximizing the efficiency of wind turbines. And he basically built a number of small wind turbines, put them in an airflow, and figured out what was the best. Actually, 2 things. One was the best type of a propeller or turbine blade, and the second thing was how closely they were spaced from each other, and how well that would, how much damage that would do to the vortices and the efficiency of the wind turbines. But I can't remember. He was, let's see, I think he was junior JD4, if I'm not mistaken. Yeah, and he was from Eagle View Middle School. And then there was Helen Wang. This was quite the project. And we really didn't even get to talk to her, but we were standing there at the adjacent project, and she was giving her presentation to one of the actual science fair judges for the whole event, and we just listened in. And so we gave her the second place award because everything about her project was just absolutely outstanding. And it was time-sensitive medicine dissolution in a microgravity environment emulated by acoustic levitation. And she actually built an acoustic levitator. She dissolved like aspirin, like little balls of aspirin in a solution, and used just standard tabletop as a control, and then put it into this microgravity that she created, emulated by acoustic levitation, and compared the results. And I kind of questioned that science, but the way that she did the project, it was just outstanding. But wasn't really in our area, but she did enough work that we said, man, that's definitely, a place, and her presentation, she should go and become an astronaut. So it was pretty good. So those are the four awards that we were given. We're going to give like $100 in the certificate to the first place winners in both senior and junior division, and $50 to the second place winners in the senior and junior division.
Bill?
Yeah.
You say second place, but I didn't see anything that really said the place on the first place.
It says outstanding,
Okay.
I think. Yeah, for outstanding. So the first place is the outstanding senior level.
And the second place is mediocre? No, I'm just kidding.
Well, it's second place.
Yeah.
Not quite up to our standards, right?
No,
Outstanding.
I would like to comment that the difference between the medicine dissolution and the gravity waves, we were having a hard time with that, and decided to go with that because we are the Deep Space Exploration Society, we were going to we were going to favor the gravity waves.
Yes, that's true.
Project.
Yeah, Lily Prime was the gravity wave, and she did a lot of research work, and the fact that she was able to go out, figure out where this data resided, and then pull it in and do analysis on it, and do various mathematical functions on the data was pretty impressive.
Yeah, she was actually she had a model of what the gravity wave should look like, and actually searched these databases for matches to the model, and found them, and was able to show a correlation graph, and including the very first gravity wave that was detected, which we got really, we were very lucky that we got a very, let's call it a very clean gravity wave right after they activated the LIGO detector that first time.
Yeah.
I forget when that came in. Didn't it come in within like within the first day of it being activated?
Yeah,
And
it wasn't long.
Yeah, they spent all sorts of time at LIGO trying to prove themselves wrong because they didn't expect to get one so quickly.
Yeah. But one of the things that surprised me about her project, she mentioned that there were over 3,000 different, not models, but filters for various different kinds of gravity waves. These were derived both theoretically and by actual detection. So anyway, so that's all I got on science fair. It was a good fair. A lot of kids had some really great projects. I wish we could have gotten to every one of them, but you only have a few hours, and we got as many as we thought were close to being top and in our area.
All
So
right,
that's
Bill,
all I got on that.
Yeah, thanks, Bill. I talked to Bill just before the meeting, a few minutes. He said he had to get these certificates made up, and looked like they were pretty good. And I'll talk to you more about signing those, so we can get them out, and the checks out to these individuals.
Yeah, I have your signature on there.
Yeah,
I didn't know how you wanted to do that, but we can take.
we can set it again and fix
Yeah.
the date on the bottom of those, and they'll be ready to go.
That's right. The date is incorrect, so thanks for catching that. Yeah.
Yeah. And Bill's been doing this for a number of years, and last year we had 4 people judge it, including Bill. And this year I want to thank Bill Thomas, Roger, and Barb for helping out on this last minute plea for help, and it all came through from our membership. Thanks a lot for doing that. Would you take about 3 or 4 hours? About 4 hours you were there?
Oh, yeah, maybe. Yeah, probably about 4.5 hours.
Okay.
Yeah.
Yeah. All right. When I was there last year, I couldn't really get in to see much because at that time there was just limited to judging folks, but there was a lot of activity going on there. It's a pretty chaos at times getting everybody lined up and where they're supposed to go.
Yeah, it's a real noisy environment.
Yeah, it is. Yeah. All right. Well, thanks a lot again. So I guess we'll go to the next one on the list is the Dan, you have a presentation on pulsar scintillation. So go ahead and start it. Oh, and I want to thank the new folks for checking in. We had 3 or 4 people show up during the Bill's talk there. So thanks for joining.
Need to change gears here or something. Not quite right.
While Dan's doing that, I didn't mention we're going to do the awards ceremony on Wednesday night, and I think Roger and Barb are going to attend. But so we'll go up and we'll do a plug for DSES as we give the awards.
Good.
What do you mean we, Bill?
What do you mean we? Well, you might have to. I had brain surgery today. I don't know if you can see that. See that? So I'm kind of bandaged up here. So I might I either wear a hat or I'll have you do it.
Okay.
All right, Dan, we see everything.
So you see slides?
Yep.
Okay, yeah, I don't know. It's seems like I don't use Zoom enough. Every time I use it, something's changed. Yeah, so tonight we're going to talk about pulsar scintillation, focusing on one particular pulsar, on some studies I've been doing with the 20-meter dish from Green Bank. And first of all, I'd like to acknowledge, I don't know how to get rid of that thing. I'd like to acknowledge the Pulsar Science Collaboratory at Green Bank, who operate this 20-meter. And within the Pulsar Science Collaboratories, the scintillation research team, and that's led by Jacob Turner and Juan Medina. And so I'm part of that team. The Pulsar Science Collaboratory is really designed to bring on board advanced high school students and especially college students that might be studying physics or astronomy or math and really want to learn more about pulsars. They have a training program set up, and then they integrate you into one of their research teams. And so I've been working with that. We access the 20-meter through the University of North Carolina Skynet, and then West Virginia University hosts the Nanograv Jupyter notebook server. So everything's done in Python there. And there's a couple of key reference papers here that were published last year that go into considerably more detail than I'll go tonight. And so the purpose here tonight is just a real quick introduction to pulsar scintillation. By observing that pulsars, the signals we get from pulsars, can be used as probes of the interstellar medium. The density variations in the ionized gas, mainly hydrogen, in the ISM cause these fluctuations. The fluctuations are what's the scintillation, where it arises in the radio signal intensity. And we can actually take measurements and learn about the size and density and distribution of the interstellar medium of the scattering structures. So these the photons from the pulsar, the radio photons, get scattered by various objects in between us and the pulsar, and we can learn some about those. And again, we're just focusing here on one pulsar from the Green Bank 20-meter. We've done presentations on pulsars in the past, and so some of what I talked tonight might be review and some won't be, but you're welcome to go look at the previous ones for some more background on pulsars. But pulsars are basically a highly magnetized, rapidly rotating neutron star. They're very exotic objects. It's the leftover crushed core from a supernova explosion. If the star started out with 10 to 25 solar masses, it'll end up as a neutron star. If it was more massive, it goes the final step down to a black hole. So neutron star is just one step away from a black hole. They're exotic. They have extreme chaotic magnetic fields that emit beams of electromagnetic radiation. And that's what we pick up as the radio waves. These neutron stars are strange, just being these tightly compacted neutrons only. And they speculate that they even have a solid crust of neutrons. And so they're still trying to learn what that crust looks like. In terms of scintillation, you can get hints of scintillation just by looking at the Presto plots like we look at here. The one on the left is our regular pulsar B0329 plus 54 that we took at Haswell last June at L-band. It's a 25-minute collect, and on the left in the circle is the time phase plot with time at the bottom going up for 25 minutes. And you can see at the very bottom, there's really a barely detectable signal, and by the time you get to the end of it, it's a decent signal, and the whole overall plot is good. But that's an indication of scintillation, where the signal, the intensity of the pulse, is fading in and out over a period of minutes to hours. On the right is a pulsar from Green Bank, and it's 0355 plus 54. So these pulsars have the same declination, but different rate of session. So they're in the same general area of the sky, but they are completely distinct pulsars. Notice that the software, the Presto software used at Haswell is identical to the software that runs at Green Bank, and it makes comparisons easy. The Green Bank one on the right is 90 minutes, and so it's not as obvious, but you can see that the intensity of the phase of the pulse kind of fades in and out there. And over the years, we've seen several of the pulsars that we collect, we've seen scintillation in them. Scintillation is this slow variation. It can cover minutes to hours in the pulsar flux intensity, and it's caused by multipath interference through the interstellar medium. The resulting scintillation, which is just the intensity modulation, can be seen in dynamic spectra. So the dynamic spectra is, it plots the pulse intensity as a function of frequency and time. Well, that's what a waterfall is. So most of you are familiar with the waterfall for your SDR, where you're looking at the signal intensity as a function of frequency and time. The difference is you're looking at narrowband. Here, we're going to be looking at a broadband waterfall. And the enhanced regions of flux density are called scintils. And on the upper left is an example of a dynamic spectrum, and the brighter regions are called scintils. So on the left is the frequency in megahertz. The Green Bank 20-meter telescope is not a research instrument, it's an educational instrument. It has, so it's 20 meters, it's a little bit bigger than ours. It has a very nice cooled front end on it, very nice cooled receiver, has 500 megahertz bandwidth. They got that really nice receiver as a hand-me-down. So when the Green Bank telescope, when the big one, when the 100-meter upgraded, then the 20-meter got this real nice receiver. So they have very nice front end. But something that we have in common with the 20-meter is the 20-meter does not calibrate the data, and neither do we. So when you're using a research instrument, then you take calibration measurements before, during, and after every observation so that you keep your instrument calibrated. So 20 meters, kind of like what we're doing. We're getting relative measurements. Nonetheless, we can get very good data and draw some strong conclusions. What we do is for 1 year, so that's one full trip around the sun, we take 2-hour observation roughly every 2 weeks. And we're using the L band. The data there at Green Bank is generated into FITS filter bank. And that's a difference also. At Haswell, we use filter bank from our GNU radio, but it's in something called SIG-PROC format, which is just a binary file with a simple header. The FITS format is considerably more complex. And so that's something we'll have to think about is in order for us to do this. And so one reason I'm doing this is I'd like to be able to do it at Haswell. And we'll talk a little bit more about that. But once we collect the data, we perform the folding just like we do at Haswell, and we remove RFI. Then we form the dynamic spectrum, which I said is just a wideband waterfall. And that's on the upper left. Then you take that dynamic spectra and you basically slide a copy of itself over the top until it matches, and you get the two-dimensional autocorrelation function. And that's the second one from the top with the bright blob in the middle. Then what you do with the autocorrelation function is at time lag 0 and frequency lag 0, you take a slice. You take a frequency slice and a time slice, and you form these one-dimensional autocorrelation functions, one in frequency and then the bottom one in time. For the second one from the bottom, which is frequency, you can measure the scintillation bandwidth, which is defined to be the half max of the frequency ACF there. And so once you fit a curve of the data, then you can get these parameters. And then the last one is the scintillation time scale, which is defined as the half width at 1/E on the time autocorrelation function. So that's how we start measuring some parameters. We basically compute the ACF and fit curves, and then just get the measurements. So a second path that we do, so again, starting on the upper left with the same dynamic spectrum, is we're going to measure the scintillation arc. And so from that same dynamic spectrum, we make what's called the secondary spectra, which is basically taking the two-dimensional FFT of the dynamic spectra. It's called secondary spectra because we've taken the fast Fourier transform twice. So this second time is what produces the arc on a pulsar that is scintillating. So if the pulsar is not scintillating, you will not see this this arc that we have there in the middle. And so once you get that arc, then again, it's just fitting a curve. In this case, it's a parabola. You can run curve fitting algorithms on it to fit the curve, and then you measure the width, the curvature. That curvature then implies a distance of a thin screen model along the line of sight. And that thin screen model dominates the pulsar scattering and accounts for it. And often you'll see that these arcs are asymmetric. That can be due to interference and the scattering or refraction, but it's also just due to the Earth's rotation around the sun. This is a thin screen model taken right from the Handbook of Pulsar Astronomy. On the left is the pulsar with its velocity. It's moving in some direction. On the far right is the Earth with its velocity. And in the middle, you have the turbulent interstellar medium, which distorts and diffracts and interferes with the radio wave coming from the pulsar. Now, that can be modeled by one or more thin screen models, and it accounts for what we observe. So the thin screen model is not necessarily real, but it does account for what we really see. The scattering in reality is due to supernova remnant shells, that they have a very hot gas that affects the radio wave, also the ionized gas clouds, and just the turbulent kind of a patchy plasma. So the interstellar space is not quiet. It's very chaotic. Now, for this particular pulsar, here's the parameters, I guess, of interest here. The distance is just a little over 1 kiloparsec, 3,200 some light years is how far away it is. It's in the direction from us over by the Perseus arm. So in this map here, this image of the Milky Way, The sun is located there. It's actually 0, 0 on the scale, but then this particular pulsar is at 358 right ascension and 54 declination. So it's over there to the left of it, near the Perseus arm, and it's just like I said, a little over 1 kiloparsec in distance, and it has a period of 156 milliseconds. We have detected this one at Haswell. It's got a 1400 flux of 23 millijanskis. So it's right at the edge of what we can detect, but we have detected this one. It took us 3 hours to detect it, but I don't know that we'd be able to do scintillation studies on it, but we would want to choose brighter ones. So just some examples now. This is from Green Bank. And the first thing you notice on the left is that data looks terrible. Yeah, you think it's Green Bank, it's in a radio quiet zone. They have some very severe noise issues there. And so right there at about 2,600 seconds, you see that big jolt of RFI. It knocked down the signal to noise. So this should always be steadily increasing for signal to noise ratio. Knocked it down to 0 and you start over. But what we can do, we have tools to remove the RFI. So we remove this, reserve the phase, and then we get this and say, oh yeah, it looks like a good strong pulse. And so we go ahead and proceed with the code, and we produce the dynamic spectrum, the autocorrelation function, and we get the secondary spectrum. And sure enough, it's got an arc there, and it's kind of asymmetric. And then we fit it. Now, it kind of depends on your eyes and I guess my screen, but if there is a red line there, but it's hard, at least hard for me to see. That's what we do for each one. We take measurements and we do it over the course of a year. What we'd like to do at Haswell is do it for 6 months. 6 months would be 2 AU. It'd be halfway around our full orbit. So it'd be from one side to the other. It'd cover a good distance. And we could put up the 1,400 feed after the last EME contest, and then leave it up for about 6 months, and every 2 weeks have a team down there just to collect the data, and then we'd post-process it. And I think there's 2 pulsars that we could do that way. Here's the next one. So this one looked a little bit better, but I trimmed off the end. So this is 5,000 seconds. It's 2-hour collection. Actually had 7,200 seconds. I just trimmed off the last part because of RFI. Got a very good strong response here. And again, here's the scintils in the dynamic spectra looking very nice and bright. Very good center ellipse there for the autocorrelation function. And then here's the secondary spectrum with the fitted curve that's kind of hard to see. But this just shows kind of arc evolution. The top 3 are, I'm calling it data 13, 14, and 15. So these are each 2 weeks apart, just showing how it changes over time. The bottom 3 are 18, 19, and 20. Again, these are roughly 2 weeks apart, just showing here it was kind of dominated on the left, just kind of in the middle, and now it's dominated on the right. So there's significant changes as we move, as the pulsar moves, and as the clouds of gas move around. Now, what we do is accumulate the data. So I've collected 24 sets of data. I had discarded several because they did not converge, too much noise. And here's some measurements, just plotting the data that we measured, the bandwidth, the time delay, and the time scale. So the bandwidth is in megahertz. It's averaging around 5 megahertz of bandwidth. And the time scale is in minutes, and it's averaging around 3 to 5 minutes. There's going to be a significant variation in the individual observations in the parameters of individually, because there's the dynamic spectra is different, and the pulsar is acting differently. What does not change is our screen distance. If we're postulating a screen distance, it should stay relatively constant even as these other parameters move around. And for this particular pulsar, there's not very much in the literature. What little I can find are reporting a dominant screen at roughly 1/10 of a kiloparsec, which would be 100 parsecs. And that's the same thing that I find. So I'm actually calculating screen distance two different ways, either a Gaussian or Lorentzian fit gets a 1/10 of a kiloparsec, and then we're also taking the arc curvature, and it's a little bit less than that. Now, along the line of sight from us to the pulsar at 1 kiloparsec is the local bubble and a supernova remnant. And so I'm not saying that it's the local bubble and this supernova remnant causing it, but that's a likely conclusion. We don't have proof of that yet, but it's likely. The models say, oh, at about 1/10 of a kiloparsec, you should have a dominant screen. And we look and say, oh, that's where the edge of the local bubble is and a supernova remnant. And you might ask, well, how in the world do I know that? Well, that's because it's been mapped out. Stella Ocker is an astronomer, and she has developed this 3D interactive visualization of pulsars that's put up on GitHub. Anybody can go get it. The sun is right here. This greenish blob is the local bubble, and each one of these is a different pulsar. There's about a dozen pulsars here. The blue line goes to the pulsar that we're interested in, 0355 plus 54 out here at 1 kiloparsec. So this is the blue pulsar, and I mean the pulsar we're looking at way out here, but it comes in and passes through the local bubble, and there's also a supernova remnant there. These other little clouds are molecular clouds and various hydrogen regions. So that's how we can say something like, well, at 1 kiloparsec, you got the edge of the local bubble, which might be causing the scintillation. Are there any questions?
Is it easy to get that information from Green Bank? You working directly with them?
Yes. So I joined the Pulsar Science Collaboratory,
Okay,
and you do everything there at their site. I don't actually, I could download the data if I wanted to, but everything's done there on their site. So it's all done remotely. The
okay.
data collection is done remotely, and all the data processing is done remotely on these Python notebooks. But they kind of help, they kind of train you and walk you through it. One reason they're doing this is big telescopes rarely will give 2 hours to a single pulsar. They might take a observation on a particular pulsar maybe for 300 seconds once a month. But that's not enough if you're doing scintillation studies, because to see the scintillation, you need about a 2-hour data collection. And so that's where we're thinking, well, we can actually offer this as a service, not only for DSES members, but also the community, where we are actually collecting useful scientific data on scintillation on these pulsars.
So we'd be at a point sometime in the future, we could do a 2 hours, collaborate with them and compare at the same time what they're doing and what we're doing. A collection of data.
Yeah, we could do that. The difference would be just in the instrumentation. So that would not be interferometer. That'd just be two separate instruments taken at the same time. The difference would be they have a better front end than we do.
Yeah. Okay.
So Dan, would you be able to upload your data to their site then?
So that's something, so Ray and I just started kicking this around. I could, or I would download the software pipeline. So I would just I had asked Jacob for permission to download the data, download the software. It's a pretty extensive software pipeline, but I think we could reproduce it here. I would, instead of generating data in our fill format, I would want to generate the data in the FITS format and then just use their pipeline. But if for some reason we didn't get rights to use their pipeline, then yeah, they would be happy to let us upload our data to there, and run it there because they're just trying to get more people, especially more schools. I did a little presentation on this to the Eads High School, but there wasn't anybody that was really interested in doing this. I think it takes a special kind of student that wants to jump into this.
Are there software tools that do the conversion between the two different formats?
They don't do it very well because I've tried in the past to convert our fill format to FITS, and it messes up the header, and then you still have to go in and work, edit the header by hand, and it's like, oh, this is not a very good process. It'd be better. So AstroPy is the big Python library, and AstroPy has FITS routines. So it'd just be a matter of using AstroPy to generate a FITS from the beginning.
Okay. Because I think I think I've played around with the FITS file formats and the headers and things, but it may not be the same FITS, but
it's been around for quite a while. FITS has been around. This is actually Pulsar FITS, and of course, Greenbank has modified the standard format. They have a custom format, but it's just they change a few columns. But FITS has been around for a while. There's still CFITS.io, which everybody uses, and then there's Python wrappers on it.
okay. Well, it might be an interesting software project for somebody.
Yeah.
You'll have to tell me more about it sometime.
Okay.
All right. Thanks, Dan. Any other questions? We'll move our head along this. Appreciate this. This is the presentation Dan was working on. And last time we had a meeting, he was under the weather. So we delayed it till this meeting here. So thanks, Dan. That's
Yeah.
great work you're doing with the Greenbank folks. So next on the list is the agenda is the noise figure versus noise temperature that Ray A0L will present. I'll let Dan check out of the
Do I still have that?
share window. There we go. And Ray, you're up.
Better turn on my microphone. Okay, very good. Let's share screen thing, I think.
Yep, hit the share green button.
And then I don't remember exactly. Oh, you see that at all?
No, you got to hit the share. The share did not work.
Okay. Get
Let's
back.
try the share again.
Oh, probably didn't hit that one.
There you go. You're in the share window now. Now click on the PowerPoint.
Now do
There
you
you
see
go.
that?
Yep.
Wonderful. Okay, very good. Well, I wanted to do a real short thing tonight. Basically, several of the people were interested in how do you get back and forth between noise figure and noise temperature. And then I got that little note down there, can a high noise figure burn my fingers? And I wasn't real sure of that. So I had to write this little series of things to see if it was going to burn my little fingers. Now, first one we'll talk about is amateur radio and radio astronomy use different measures for basically the same thing. And that is radio generally uses or measures receiver noise contribution in decibels. And the typical one for us and our little preamps that we build, uncooled preamps, are about 0.4 dB. Do a little better than that occasionally, but 0.4 is a pretty normal temperature for our noise figure for our preamps. And that's pretty much across all the frequency. We go from about 400 megahertz at the lower end, and then we go up to about 2 gigahertz, a little under that. And most all of our noise temperatures or noise figures come out to be around half a dB or less. And radio astronomers use temperature in degrees Kelvin, and a typical number would be around 25 degrees Kelvin temperature. And basically that's a load resistor or a resistor that puts out at the same amount of noise as your receiver at about 25 degrees Kelvin. Now, I understand 25 degrees Kelvin is a little colder than I'm used to, even though I'm from Minnesota, but it'd be make for some awful good ice fishing. Okay, and the reference temperature that you use for most of this, the reference is 290 degrees Kelvin, which is a little over 60 degrees room temperature or Fahrenheit. And so that's the reference. Now we'll go on into calculations. First of all, I'll define it a little bit. The system noise figure is measured at the antenna connections or preamp output input. It's the noise contributions from the amplifiers, coax connectors, filters, etc. And remember last time the cascade noise equation works into that, because you have to pretty much figure out all of your gains and all of the losses in your whole receiving system to come up with a final number. System noise temperature is the temperature of a terminating resistance that produces the same noise as the receiving system. For measurements, noise figure stated in dBs, which is a logarithmic function. So for our equipment, it's normally less than 1 dB, as I stated. The noise temperature is stated in degrees Kelvin. 0 degrees Kelvin is absolute zero, and the lowest temperature theoretically possible. So now we've got a starting place for doing our figuring. Noise temperature is equal to 290 times the noise factor minus 1. And remember that you get noise factor, noise figure is in dB, so it's a logarithmic scale, and you have to, noise factor is just converting that to a linear scale. And then we can do the mathematics after that. So then you get from noise figure to noise factor by taking 10 and raising it to the noise figure divided by 10 number. Example, find the noise figure 3 dB noise factor, 3 dB, let's consider a 3 dB noise figure. So noise factor is equal to 10 raised to the 3 divided by 10, which turns out to be 2. So an increase in 3 dB is a factor of 2, and you often hear that, or a decrease of minus 3 dB is a factor of 1/2. That's where that comes from. Noise temperature is 290 degrees times the noise factor minus 1, which in this case, at 3 dB noise figure turns out to be 290 degrees, our reference temperature. So noise temperature, noise figure conversion. Up on top, you can see noise figure is equal to 10 times the log of the noise factor, and notice that I change noise factor is capital letters and noise figure are small letters. So that's when you see that in the literature, that's what they're talking about. Noise factor is capital letters. So you have to get it to noise figure to noise factor. And then the noise temperature divided by 290 plus 1 is the noise factor. So now take an example, you can convert 35-degree noise temperature, which would be a very good preamp, and to noise figure in dB. So you take the noise figure 35 divided by 290 to get noise factor. 35 or noise temperature divided by 290 plus 1 gives you 1.12. And then the noise figure, the little ones, is equal to 10 times the log of the noise factor, which in this case comes out to be right under a 0.5 dB. It's just barely under that, 0.492 or something like that I computed. So that's the mathematics. Now we'll make it simpler. Noise figure is a figure of merit of receiver. Yeah, and then noise factor. Noise factor is a noise figure in dB converted to a linear equivalent. And the two of the most common ones are 3 dB is equal to a noise figure of 2 up, or noise factor of 2 up, 2 down. And then 10 dB, you would have a noise factor of 10. The noise temperature, the temperature in degrees Kelvin of the terminating resistor that produces the same noise as the electronics that you're using, LNAs, things like that. So now I went ahead and worked it out for you for various common noise figures, 0.1, 0.2, 3, 4, 5, up to 1, 2, 3, and 5 dB. Those would be all range. 5 dB is something that would be typical for a SDR, something like that would be running up in the 5 dB range. But our preamps that are much better than that go all the way down to, in our case, about 0.3 to 0.4 dB. So you can see on the right, the noise factor equivalent is in the noise temperature on the right-hand side. So we very often have a noise temperature of around 30 degrees or so, somewhere in there, 30, 35 degrees. Now, that of course suffers loss because added temperature, because of any relays that you have, any coaxial cables that you have, any connectors that you have. So that's why we tend to mount these things right at the feet if we can help it, or with a very short piece of low loss coax between them if we can. But so that gives you some sort of an idea of the numbers. Now we'll go from there. If you look at any of these, and I think we can put them on the website, but there's 4 different places where you can go with your computer and just type in the numbers, and it does all the calculations for you, and it doesn't make half the mistakes I make. So that's very good. And then this is a graph of what noise figure to noise temperature. So you can look it up. It's very easy. It's not real accurate when you get down below 1 dB, but you can guesstimate. It's pretty good. And I believe that's pretty much it. So that's all for tonight.
Any questions for Ray? A lot of
Ray, I
knowns
don't
and
remember.
unknowns
Do
about
we-
preamps, and what's the best one to use frequency wise you're operating, or so give you a better understanding of when you see the numbers, what they all mean.
Do we have any estimate of what our system temperature is, the overall system?
The only time we've ever actually measured it, we came out with it seems to me it was between 150 and 200 degrees, and that was done at 400 megahertz, I believe. And that one, Rich Russell and I did a long time ago. But that was the only one that we've ever actually tried to study and do. We seem to not get down there enough to take some time and actually just sit back and calculate that and look at it.
Mm-hmm.
I suspect we're running generally right now between 50 and 100 degrees.
Okay. Any other questions for Ray? Comments? All right, we'll move on to Paul Sabone with the DUBIS contest. And before he flips on his, you want to unshare your presentation there? There you go. One quick comment. I forgot to mention the school science fair that Bill commented on. The monetary prizes we give for this comes out of our educational fund. And this educational fund was started some years ago with $800 that we had on the sale of a propane tank and some propane that we no longer needed on site. And then we started a building fund, and that money was replaced by a grant, the building fund money. So we decided to convert that savings account to an educational fund, and it was reimbursed. We were fortunate enough to get 2 $1,000 grants from the MLB Foundation through the Denver Foundation. The most recent one came in December, and that money goes in the educational fund. It funds these prizes as well as it funds our educational first time event we had out on the site with the was it La Junta schools or Los Animas? I can't remember. Doug, what was it?
Los Animas.
Los Animas, yeah, Los Animas School. And Doug's working on another project as well. So with the college down there, so we'll have more about that. Anyway, that's where the money comes from. So we got a set aside account again, thanks to the MLB Foundation for providing those funds. Okay, Paul, you're up.
Found the unmute button.
Pardon?
Thank you very much, guys. And
Okay.
this is Paul Savon, NO0T. And what we're talking about here is the DUBIS contest. So that is a European contest. Let me see if I can just put a little share on here. See if I've got it around here somewhere. There it is. Okay, so this is the EME contest that's coming up in April. We're on the 1.2 gigahertz segment here, and it's a 24-hour contest. It's the third part of their 7-part contest season. And at the moment, we're just going to be on 1.2 because that's all we've got right now. And this is last year, I forget what we were doing. I think we're in the top 10 somewhere around there. But it's primarily a CW contest. And this year, we're going to be trying to take advantage of the fact that we have a new feed and a much better receiver, transverter, and also a lot more power. So a lot more people will start hearing us. And so our objective this year is to see if we can make it to the top of that list, be in first place. And so this year we're going to try a very serious multi-op effort here. And we're going to be trying to see if we can pull in all the CW operators. You don't have to be 30 words a minute. In fact, we discourage people who send 30 words a minute because that's kind of hard for some people to copy off the moon with some people have fading and a few other things. So something around 10 to 15 words a minute is pretty much standard on the off the moon. Anyway, so the contest actually starts a little bit on Friday night. It starts at 0100 UTC, which is around, I think it's around 6 o'clock. This is in April, and it runs until the moon goes down. And so that's kind of, we just have to watch when the moon goes down, and that's going to be our time for that Friday night. Then it picks up again on Saturday morning, and it runs till the moon goes down. And then same thing on Sunday. And I think it only has about maybe 2 hours left on Sunday before the moon sets on Sunday morning. So those are the, I'm sorry, it had 2 hours left because I think that's when when our window is gone. Anyway, that's kind of the session. We're going to be offering. It's going to be some really great cooking by Alex. Alex is going to be one of our chefs. We have a couple of other people who are really good at cooking, and I'm going to give my hand at doing some fantastic meals. So lots of food, and we're going to have sleeping quarters there in the main part of the building. And hopefully we can find maybe some folks who can operate remote from Australia. If we're lucky, we can get some CW operating from over there too. We have the capability of operating remote with our system. The system that we're going to be using this year is going to be brand new, and Alex is going to be providing training sessions for those who need to understand how it works and etc. So I'm going to have to go through a training session myself. Anyway, so it's basically you work as many stations as you can, and they're going to be using the grid as a multiplier. So I think that's about it. Any questions or comments?
Yeah, Paul, is the contest, does the contest roll all these different parts together as one award, or is each one of them independent? Because they're all different frequencies, so I'm wondering, how do you win it if you don't operate all frequencies?
Well, okay, so each band has their own, like for instance, the 23 centimeter part, which is what we're in, is called the VK3UM Memorial EME Contest. And so that's going to be it. Now, I don't know if there probably is an overall winner, but I don't think that's public. I don't remember seeing anybody who's got all the bands in there. I think a lot of this is, if you notice, some of the contests are only 24 hours in length, because the most popular band is going to be the 23 centimeter band, which is what we're going to be operating. But if you see at the top of the page here, the 70 centimeter part is these are memorials for Silent Keys that are named after that part of the contest.
Okay.
Does that make sense?
Yeah, I was just wondering how they scored this thing, if they had all these parts, if they score had to do with multiple parts or just one part.
Well, yeah. There is I didn't bring it up, but if when they do the results, you can see them by band. And so we're going to be trying for the 23 centimeter part. And then next year, if we have the 2.3 gigahertz up and running, we'd like to, that's on March the 8th, be able to do that one as well. That's only a 24-hour contest, but I'd like to get us at least on the list there for the 2.3 gigahertz and see how much power we can run. And then if we get, really ambitious, we may go for the 3.4 and in the 5.7 gigahertz parts if our dish will handle it. Any other questions or comments, or did I answer your question?
Yeah.
Okay.
Yeah, but wouldn't if you're talking about those other bands, wouldn't you have to have completely separate package transverter?
Well, there's an interesting answer to that, and Alec has it for you.
Okay.
Yeah, well, I can add a couple comments to what Paul said, and Bill, what you asked. Each frequency, it's treated as a section. So, and winner in that section would be nominated and awarded separately. So some of EME guys across the world, they have all actually bands and participate. So, and they're looking for the total scores are going to be awarded separately. So if you choose to run just 1296, you'll be competing in the 4 actual sections: QRP, QRO, just CWSSB, regardless of the power and the operator. So each frequency has all subsections. So in our case, we'll go be competing against anyone around the world on the 1296. But the also separation by ERP, estimated isotropic radiated power. So we are definitely above 600, and that's why kilowatt, because we're in the megawatt section. So we're definitely going to be the strongest ERP. So that's why some of participants raised concern last time. I think is worth to mention, because when you're running a high power and you the strongest station, and some people they're trying to compete in the same subsection, they can't compete because they know they're not going to hear or people not going to hear them. So that's one of the things they consider, running high power. So it's just other people don't think this is fair. So I think they will limit eventually, because European actually kind of concerned about that. But anyway, other thing I want to bring up about the frequencies, actually planning to 432 and 2.3. I do have 2 packages ready. One produces roughly about 300 watts on 432. It's the same exactly size as the Diane package. It all goes into the feed, or actually can be located outside, since we can run just the cable with minimal losses on 432 instead of putting this on top. But either one, it's going to work either in inside the hub or in the shack. So the other package is 23 centimeters. As right now, I have roughly about 30 watts, but the gain on 13 centimeters, kind of higher than 1296, I would suspect is going to be over 53 dB gain. So 30 watts is significant power. I did a couple experiments last time using Diane package, and I ran 5 watts only. So I was able to just minimize my output power to minimal possible, which was 5 watts. According to the power meter, I was successful run at least 3-4 kills. So it was fun to see how people respond to you. So the power isn't the problem. So we have a enormous game. And the last thing is disappointing thing, Paul. I'm not going to be able to attend the contest. So I just learned that I actually have a flight in Roatan, and that day I will be returning back to US. And kind of disappointed because I cannot cancel that, cannot move it. It's all settled, and I have to give up on the contest. So no food for me. I apologize, but before contest, I'll be 2 times at least in the Haswell. Am I gonna feel that guilt so I can cook?
Alex, what day are you coming back?
I'm flying on 6 morning, on Sunday morning.
Oh, Sunday morning. Okay, well, that cuts that out then.
Yeah. So and also Mark mentioned that he's not CW operator. But also, you don't need to run only CW. Your category is CW and SSB. There is no separation. So you can run actually CW and SSB combined. So it will be competing in the same section. Just FYI.
Yeah, 90%, 99% of the contacts though are going to be on CW, because that's where a lot of the weak stations, the ones we want to get, are going to be below the big stations can operate sideband, but it's you will probably already have worked them on CW.
As long as you hear the station will hear you. That's 100% guaranteed.
Right. So that's why we're hopefully we'll be able to hear more. Anyway, that's going to be the plan there. I'll be talking to you more about some operating tips. Maybe you can give me later on how to do how I can listen and not have to worry about the Doppler shift. That's kind of the
Okay,
thing.
so please take advantage of me being there because I'm getting ready to drive on Wednesday.
Yes.
Everything is arranged, and the system is just final run here. I kept it on and just see what's going to happen overnight and tomorrow. So everyone who want to learn the system operation, it's totally different Diana operation. A lot more, I'd say, complicated, but trust me, it's a simplified version. But it'll give you a lot more understanding how the system perform in all ways. So, and anyone welcome to attend to train, especially those people who will be participating in a contest. So and Paul will get more knowledge as a chief guy in quotes, so he will know beyond just looking at the monitor. I'll make that happen.
All right, good. Thank you very much. And let me unshare here.
Alex? This
Go
is
ahead.
Roger.
Go ahead, Roger.
Yeah, could you send me, I can't remember if your email included it, the center to center dimensions of the 2 pins that you added to the back of the Eve package. So center to center distances, and also the distance of the pins above the surface that Diane would rest on. Do you know what I mean by that?
Yeah, absolutely, 100%. Yeah, I believe I sent it, but I'm not gonna look into back to find that email, so I will just measure it again and send it. So you want a height from the ground, and as well the separation between 2 pins.
Exactly. Thank you.
Yeah, will do.
Any other questions? By the way, you're going to be, maybe this is going to be covered later, but we might as well say it now. So you're driving up from Phoenix to Platteville and Greeley on Wednesday. That's day after tomorrow. And then the testing will take place on Thursday and Friday. Is that correct?
Yeah, I'm in touch with Dave, Alpha Zero Radio Sugar. I already outlined the test plan. I didn't share with the rest of the team because anyone welcome to come and attend testing. And I think I don't know, Paul, if you want to come there because this is when the system going to be taking initial test, and this is how find out what we actually having an output that's never been tested before. So yeah, I'm driving on Wednesday early morning around 4 a.m. from Phoenix. We have same time here, so no time difference. The same time is good, and I will drive to Platteville, and I'm gonna stay there at least for one night because I want to make sure that in case if something needs to be fixed or manufactured or make a cable, let's say, or something, or we need some emergencies going on, I will stay for another day. So Thursday reserved 100% for RF testing. Friday also reserved in case if something is wrong and we couldn't finish on Thursday. If not, on Friday morning, I will drive to Haswell. That's the plan. So I can stay another night and early morning drive to Haswell and be there in 2 hours or so. And then if not, I'll be in the Haswell Friday night and then spend the rest of the time till probably Sunday midday or afternoon in Haswell until the system going to be tested in any way where we're planning to do so. And majority of people are going to be there, so we need help installing the system and doing some initial tests. And eventually, if everything goes well, we'll do some EME.
Yeah, so we'll do some EMA testing probably on Saturday, Sunday then. Once we got some RF going out the pipe.
Alex, let me interrupt you for a second, Paul.
Go
I've
ahead.
got the spare amplifier that came in the mail, and I'm wondering if you want to pick that up on your way through to Platteville, or how you want to handle that.
Were you located in Colorado Springs?
Yeah, I'm in Colorado Springs. I could even, so you're going to come through Colorado Springs on Wednesday?
Yeah, I guess around after 3 o'clock or something, maybe around 4.
Yeah, I could, what I could do is, it's kind of a diversion for you to come to my house, and that at that time of day the traffic's heavy. So what I could do is meet you on the highway, meet you near I-25, like at Village Inn on I-25 or something. And
Yeah, I'm looking at the Google map. I don't recall exactly, but yeah, I'll be passing Colorado Spring according to my map. Yeah, so I can give you a heads up when I'm going to be approaching to Colorado Springs, so at least like an hour or so.
yeah,
And
that would be good. You could just call my cell phone and then I could bring it over.
so perfect, somewhere along the highway, so I can stop by at the gas station or somewhere, so you can. I'll be on the 2025 highway. Looks like.
Yeah, it looks like I-25 and Garden of the Gods Road would be the most convenient place.
All right, perfect. That sounds good. So because we need that amplifier at Haswell.
Yeah.
And we'll take all spare parts. I think that's only one that in there with you. Everything else, I have some spare parts I'm taking with me, and I also manufacture extra spare parts in case if we need to replace quickly in the Platteville. And then everything else will just be we'll need some box or something, and I will walk through. Ray, you're coming, right? Well, of course you're coming. When you coming, Ray? You coming on the? He put just the headset. Ray, do you hear me? Ray?
Yeah, he hears you.
Well, Ray's getting back online. Alex, if you would just announce when you plan to be at Haswell using the group IO. And, I'm basically holding some days open, and it just depends when you're going to be there is when I'm going to be there. So if you just sent out and, did a post on group IO, oh, there you are. I suppose I could do that as well. If you just send out an email on group IO, and that way, you don't have to notify a bunch of people. The people who are going to be there are going to be there then.
Yeah, sure, absolutely. Well, there is a core people I need. I need you, I need Paul, I need Ray, for sure. Bill, I guess Bill gonna be there or not, but I need at least you and Ray for sure for mechanical work, and I need Paul to learn the system for the Dubus contest. Now, anyone else would be additional help because we might need some extra hands. And also people who want to learn how the system works. And there would be some change in the system, so I have to fly. Unfortunately, I don't have a time to do it now. I'm waiting for the part to arrive, which can arrive in a few days. And then I'll take a weekend and a fly to Denver, take a car, or maybe someone want to meet me at the airport. It's just a couple hours deal that I need to replace one board. It won't affect us right now. It's something that needs to be done eventually. I'd like to do as soon as possible. And other than that, I don't have anything else. The system looks good. I send out pictures to Paul and Myron. How the system looks right now is all connected, and we'll need to just install it. Any other questions?
You want
Yeah,
that?
Ray, you was muted. I did not hear when you replied. I was going to ask what day you're coming to Haswell. Are you planning to be on Friday?
I will be there Friday and Saturday, whatever it takes.
All right. Well, as I said, I'm planning to be at Haswell on Friday. It's going to be either morning or late evening, depends how the test's going to go in the platform. And then, but it's either going to be a Friday, not necessarily Friday. I will be able to do anything, but Saturday morning and entire Saturday would be the day for all of us to do everything we could.
Yeah, very good. Yeah, all the parts are down there already.
Awesome. Thank you.
I'm heading down on Wednesday to reinstall the 705 and the computer and the monitors. And Alex, I don't know how many monitors you need, but sounds like you need a few.
Since you mentioned, unlike previous Diane system, which I actually also taking with me as a backup system, and as well, I don't need to have a T system, so I'm taking, since I'm driving, it's easy for me to take everything. Unlike a Diane system, we have additional SDR already as a subsequent IF. So I made a little bit convenient system. So you have two independent IF receivers, but only one that has transmitter, which is the turns off the receiver. It's everything all taken care. So therefore, you can have two computers separately, which gonna run completely different software. One gonna run SDR and second gonna run your IF from 75. So if say the two monitors and Myron, look at my monitor, I have wide 49-inch curved monitor, which is you can and it's a very high resolution, about 6,000 pixels. So you can put multiple windows here, and I really like. So if we had something like this, it would definitely fit all windows on one monitor. But Diane would, I'm sorry, the EF25 would have at least 4 windows open. That's for the monitoring and control. Then we need WSUT software. Then we need to SDR software, and then we will need as well as 2 spectrum analyzers. That's going to be running in parallel, similar like we had for EME contest, if you remember. So we no longer need a camera, so that's not the window. So we're talking about roughly at least 6 windows. If all those 2 monitors are sufficient to feed those 6 windows, then it's all okay. If not, we can always use a laptop and put like an extra monitor connected to the laptop and use as additional screen. So it's up to you to decide, but you're going to have a 2 independent CFDR software. If one catches, there's another, and we're going to record continuously. We're going to continuously record the spectrum, regardless of what we're doing. So I will go through all of that when I get to the Haswell. And if you want to take something with you, extra monitor, please do so. You can always take it back, but we need as more eyes as possible.
Oh, there's still 2 24-inch monitors on your bench in the radio room that haven't been used yet.
One of those is actually being used by the dish software, or the dish control software.
So you're using 3 on the main console?
Right now, yeah, one of them is over where the control is for the dish controls for the I can't remember the name of the software now.
Well, anyway, they're all I'm saying is there's 4 24-inch.
There's one left, and
monitors.
may not be a bad idea if we get something like a 4 monitor
Stand or something. Yeah.
Something that'll hold 4 monitors.
Yeah.
That would help us a lot. it also looked really cool.
So because you can always add something. I mean, we still have a time till execution date, roughly about a month from now, or less a little bit because we have less days in February. So we still have, time to decide what we're gonna do with it. The most important stuff is the system is should be fully functional by then. So, and also I want to mention, I told that to Myron. I'm working on the board with the name tags. So since I have all these tools at home, I can do a lot of engraving and laser cutting and all of that stuff. So I decided to make a board with all members of the DSES and hanging there. So it's going to be just a board with the tags, but like this, I'll bring later and show. So I have all call signs, and I'll print out the call signs first, and then just individuals that don't have amateur radio call signs. And we're going to find a place somewhere on the wall we can hang in that wall and clip those tags on it, so we know what how many people we total have in DCS.
Yeah, I had the opportunity to visit Alex's QTH last Wednesday and viewed his workshop as well as ham station. And his workshop is very impressive. And he showed me what he was engraving, laser engraving. They really look first class on the call sign plates. The monitor in his ham shack, that 49-inch curved monitor, I was very impressed with that. The quality, the resolution, you can get a lot of stuff on that curved monitor. It's 49 inches, it's pricey, but we'll have to talk to the board about, see if it's in the budget through the grant. We could easily replace all the current monitors with one. And that's something we need to talk about. It's not something we need. It's something to be nice to have, we can do with what we got already. Bill found some monitors, and there you go. That's one of the engravers there. So
you can also, if you're going to have a lot of visitors, you can also have a lot of fun. You can put one waterfall on the projector.
Yeah.
And have a huge one on the wall. It'd be really impressive as hell.
Yeah. The resolution that he had on the screen and what you can see on that 49-inch monitor is pretty.
Oh yeah, it's probably good, a 4K monitor.
Yeah, it's pretty impressive. So we'll talk about that later on, but you say we got a month to go before we even get to that point. Hopefully we decide to go that route. We can make a decision in 2 to 3 weeks, but again, that's something that'd be nice to have, but it's not something we need to have right now. So we'll discuss it.
That's good. All right. Anything else that am I responsible for today, Myron?
I think that covers pretty much on the agenda. Open discussions coming up. I'm sitting outside here in the RV park in Mesa, Arizona. I'm in the dark. I got some lights on my little table here shining on me. Using Starlink for my internet, and I tell you what, that's really impressed with the Starlink system, and it provides a lot. My brother's using it. He's down the way there, and he's signed on to my router, so we're streaming a lot of stuff, and still got a lot of bandwidth, and it works great.
I agree. One question for Mike K0FYR. Are you planning to come down, Mike, and do any of your famous videos?
Yeah. I've been laid up. I had surgery on my Achilles, and so I'm just coming off of that. But yeah, I was gonna try to go there on Saturday, and that'll probably be my first video since December. Since I've been out of pocket. So yeah, I was gonna plan to head up either Friday or Saturday and do some initial with the testing, and then for sure when we do the event. I was planning on being there.
Sounds good.
We had some other interest from for the actual EVE event. Who's on here right now? One of our new members, Pat McDivitt. He shows interest. He's talking about getting a hotel room. So we need to narrow down those dates in March. So people who want to go down there and spend some time and spend the night at the Cobblestone Inn in Eads can have some reservations there. So that's something to think about when we start narrowing down the actual date in March.
Yeah, it'll be March the 22nd and 23rd, and maybe the 24th.
Okay. And Paul, you still having the Zoom meetings on Wednesdays with the technical group?
Correct. Yeah.
Okay.
And we're going to be trying to nail down the times, who's going to collect the data, come up with, who does what when,
Yeah.
sort of thing. Because there's a lot of moving parts here.
Yeah, I understand. I've been looking at all the people attending and from around the world, and it's a pretty impressive group of folks.
Might be interesting to see if you put a small camera up there somewhere and stick it on a Zoom for the event.
Yeah, that's possible.
And because I would sure like to see it.
Yeah. Well, that's something we easily.
I'm being purely selfish at that point. I'd really like to have to be able to see it go on.
Everyone want to see when you're going to fire up 62 megawatts power into ozone layer.
Yeah.
We don't talk about that. It's like the fight club. We never talk about it.
We need to call FIA. We need to call FIA and NORAD and let them know.
Now be careful, because a couple of years ago we had a conspiracy theorist say we were modifying the weather in eastern Colorado, and that was up on the web. And so don't say
we don't need the FCC visiting us, okay? Let's just keep it quiet.
Grow some turkeys.
Yeah, we'll do some turkeys. That's another way to cook food.
No, and speaking on that, and I already talked about this with Paul. We would need to have sort of like a siren or something like an audible, which I can connect and control by the system, and when we're going to transmit, so it's going to indicate. Because the concern would be when at low angle elevation, even though the beam width is still very narrow, but power is no joke. So we want like anyone to be in near proximity of antenna where the system is running. So something that will alarm people that, hey, we're transmitting. Because this is a thing is very common when you transmit big power.
You need to find some flash bulbs somewhere to pass out.
Well, when we're transmitting, everybody has to be in the building, okay?
I will refer this to manager of a 5. I'm just design engineer.
Consider too that the power density in front of the dish is still, it's not 65 megawatts, right? You're only putting 1,500 watts into the dish, and that's distributed over the whole area of the dish. So the power density out in front of the dish for an individual, probably about 20 watts.
There's only one house to the east of us.
It could heat up your ears.
Bill, that's only one way to find out.
You can stand out in front of it and tell us how it feels.
I do have a portable meter that I use because I'm a guy that running EMIMC. I'm running 20 volts per meter on 40 gigahertz, and trust me, it's gonna kill. And it's gonna pop if it's beam gonna be in your eyes just pop right like a popcorn. So I have a special meter that measures the field strength. It would be actually interesting when we're going to fire up and walk around the dish. And I'm going to volunteer because I understand all these things. And then measure is anywhere else we have a dangerous level. But I doubt it. The beam width is very narrow, but still we don't know. And that's the hardest part to understand. We don't know how the beam width, how the side lobes are, what the spillover is, and those things. So we just can and presume that everything is perfect, but I'm not a perfect guy.
Safety first. Okay, that's enough.
We'll let Ray walk around with that meter because he's used to being on Cheyenne Mountain where the field strength is off the chart.
Yeah.
I don't want to volunteer with me walking in case if I'm going to fall bad, so someone can take over.
So
you never know when the FBI repeater is going to go off, right?
Who
We're
wants to
gonna
look like
at the
bacon?
map and see, well, come on, there's nothing going on. It's the middle of the desert. What's going on there?
Who wants to look like bacon?
Yeah,
All right, well, let's go,
I
guys.
think we're losing control.
Yeah,
What
yeah.
what little control we had. All
So,
right,
so,
thanks,
so
Paul.
Mike K0 FYR, you do not mention ERP in any of your videos, okay?
Yeah, I don't want to.
Just no ERP, because I don't want to get in trouble.
Okay.
They're going to come, seriously, the FCC will come and say, can we measure this? For there's a certain amount that I don't want them to get into it anyway.
Okay.
Is there anybody left at the FCC at this point?
That's true.
Thanks a lot, everybody, for joining in. The saga continues. Safe travels, Alex. I was going to mail you a check, but obviously you'll be long gone by the time it gets to you. So you want me to hold the check or what?
Yeah.
Yes.
Yeah, you're here. I forgot. So.
What's that again?
So you're not gonna join us for the test, right? So you're gonna.
No, I'm still being Mesa.
Yeah. Well, when I get back, then I'll meet you up.
Okay. I hope to meet you down there, but you'll probably be too busy for me to even stop by. I won't be able to get there till Wednesday anyway, so you'll be long gone by then.
Yeah, it's okay. Don't worry. It's no rush.
Yeah. Okay. We'll meet when you get back.
Myron, if
Yes.
you, I pasted in the chat there.
Yeah, I saw that.
Yeah, if you want to go for just one large monitor instead of lots of little monitors, you can't beat $230.
Yeah, I saw that. Yeah. Well, we need to make sure, it's a, computer monitor quality, 4K, curve monitor. I tell you what, it being that curve monitor and have it sitting in front of you, you can very easily see everything pretty easily. So, yeah. Thanks a lot. We'll check that one out as well, Roger. Any other comments? I got to check out of here. So continue on if you want to. Everyone have a great evening. Thanks for joining.